we'll hand it over to Neil Mitchell, who's going to give the first talk on drive-by Haskell contributions.
Thank you very much. Is the mic working? Fantastic, sounds like it is. Well, thank you very much for inviting me. I'm looking forward to a weekend of hacking. So before I start, can everyone in the room who maintains a project they're going to be working on this weekend stick their hand up? Okay, a small spattering. And can every beginner who's looking for a project to work on stick their hands up? Okay, so maybe a few more beginners than there are maintainers. That's great, because my talk is mostly focused at the beginners, but hopefully the maintainers will get something out of it too. So when I got my speaking slot, and I found it was the very first thing in the first day, I thought, what's the best way to open a hackathon? Well, drive-by Haskell contributions. How can you start contributing to a Haskell project? So imagine you're a beginner, you're looking for a Haskell project, you find a Haskell project, you see the foundation library, the Haskell blog thing, the Warp web server. These are cool. How can you get started? How can you make your first forays into contributing to that project? So thinking about it, you can obviously go through the bug tracker and solve the real bugs that people are having, but often that can be quite a big leap. It requires a lot of knowledge about the project. If they were trivial, the maintainer would have probably just fixed them already, and thus they're maybe not the best thing for a beginner to start on. So instead I was thinking, what are the things that beginners can always start on a project? I kind of ended up dividing it into 4 categories. So you can improve the docs, you can run static checkers, you can test it, or you can improve the performance. And pretty much every project would benefit from those 4 things happening to it. Of course, these are also ideas, so if you are a maintainer and you're kind of looking for some low-hanging fruit to pick on your project, these things might also be useful. So very much this talk is about starting at the bottom and working your way up to more fun things on a project. So as a maintainer, if I get a few patches from someone which are simple and good, I'm much more likely to trust them with bigger things. I'm much more likely to engage with them about the bigger things because they've built up my trust. So it's all about starting small, and in many ways, you're starting here, you're tugging on a thread, you're trying to pull yourself up to the more interesting and more complicated things in the project, and the way to do that is by starting small. So start with a typo and work your way up from there. So most of this talk is going to be actual technical things you can do to a project to see about how you would start it and what's the right way to start. But before I kind of get there, the first question is, if you make a change to a project, will it be welcome? And this is kind of the checklist I go through before I bother to submit a pull request to someone, before I bother to even see if I can solve the problem I'm having with a library. So firstly, is the project on GitHub? Maybe some people have moral objections to GitHub, but personally, if it's not on GitHub, I don't bother. It's a good sign that the project is modern. If it's an old project, they've probably moved version control, hosting things more than once. And if it's on GitHub, that's a good sign that they care, and you kind of know the workflow they're expecting. They don't expect a patch to a mailing list, they expect a pull request. Next thing is look at the open pull requests. Have other people tried to contribute to this project, and have they got nowhere? Have they got no responses? Having open pull requests isn't a bad thing, but having open pull requests with no comments on is. When was the last commit? Does the maintainer still seem engaged with this project? You know, maybe it hasn't been committed to for a year, and that's no problem. But in that case, does it still build with the latest GHC? Is it in stackage? Have they done all the things that you expect a project that was languishing to have not done? I mean, this isn't saying don't contribute. Maybe you can be the one to kind of get it working with the latest GHC, but you're probably not going to be, you're probably looking to take over maintainership there rather than just contribute. Another thing that people often forget, you know, don't just contribute for the sake of contributing, because you'll get bored quickly, and the maintainer, if no one's using their thing, they don't want to bother making releases and doing all that stuff. So only really bother contributing to things you believe in and would like to use in the future, or you do use, because otherwise you're going to run out of motivation very quickly. Is there a contribution policy for the package? Doesn't have to be one, but if there is, read it. Does it seem friendly? And I would always say, if you're going to spend like a week hacking on something, make sure the maintainer kind of agrees with your idea first. Otherwise, you're going to waste your time. So these are two contribution policies, portions of contribution policies from Haskell projects I've contributed to. I'll give you a second just to read these. So they're very different. One is friendly and welcoming. The other tells me that in order to contribute to this Haskell project, I need to go away and read the Git manual for a few weeks. So perhaps try and pick a project that you think will be friendly to you rather than actively hostile to you. And the kind of final warning before I get on to the technical things, don't rearrange the deck chairs. So as a maintainer, I love getting pull requests, and I really appreciate the effort people put into the pull requests. But sometimes the change, while well-intentioned, just kind of moves things from this pile to this pile. It isn't really strictly beneficial. And then I'm left with the kind of awkward, well, I don't want to say no, because I am grateful for the pull request, but at the same time, if the pull request didn't come from a person, I'd probably reject it. So try and make sure your pull requests are strictly beneficial. So there are things I could do as a maintainer, like turn on wall or re-indent, that are fine, that I probably don't really want as a pull request. Okay, and now on to the actual, what can you do to a project to improve it? So the first thing you can do is build it and use it. And in doing so, you may find that it's really hard to build and use it because the documentation sucks. So it's often said that Haskell projects have terrible documentation. I don't think this is remotely true, because often the type signature is perfectly correct documentation, and with a little bit of knowledge of the library, that type signature is, that's what I really, really want. And even the other bits, like the readmes and the haddocks, they're not too bad. But that isn't universally true. So the tip I got given for writing readmes, or the first page of the readme, the first kind of screenful, is that it should say what the library does. It should say why you should use it, and it should say how to use it. If you go to a random project you like, and it doesn't say this, maybe consider submitting a pull request to modify it. So I've seen entire articles on Reddit about the FOB system, which go into intricate technical detail on the FOB system without saying what FOB is. So this is the kind of standard problem that maintainers never think to address, because of course they know exactly what their project does. And they know exactly why you should use it, because they bothered to write it, which was a massive investment. So it's clearly useful to them. But it's not, this is not something other people know. So this is where beginners are really much better than maintainers. I will say, if you have any questions or even thoughts or suggestions that I've missed, do stick your hand up and contribute them. So for Haskell projects, typically you've got the README documentation, and then you've got the haddock documentation, which is each function documented individually. So after you've seen the README, after you've got started, you want to start using more functions in the library. And here, you look at the haddock documentation. So are the functions clear? Are more examples required? The answer to this is almost always yes for most projects. So for the README, you kind of expect someone to kind of scan through it linearly. For haddock, you expect people to jump in and out, randomly following hyperlinks and search tools. So you really want much more documentation, and you almost want duplication of information or easy hyperlinking between it. Are the corner cases clear? Often the answer is no. What does it do on the empty list? Does it throw? Is it obvious? The other thing is documentation. When you send a pull request for documentation to a function, you're really telling the maintainer two things. I couldn't figure out what this function did without some more documentation, and this is my guess of what that best documentation should be. So don't be afraid to send incorrect haddock documentation comments, because really, you're just raising a bug that you didn't understand it, and being extra nice by giving them a hint what you think it might be. You might be wrong, but if so, the maintainer should probably help you. When looking at haddock, a lot of this talk is using tools to help you find on those threads you can pull at. And there is a tool for finding out what haddock comments are missing, and it's generated by haddock, and it's useless. Don't use it. It reports every module that has an exported identifier which is not documented, which is distinct from every exposed module that has an identifier that is not documented, which is what you really care about. So someone may want to write a tool to scan for missing haddocks. I have one, but it's kind of a little bit of hacky grepping on top of the haddock minus Hugel output. Okay, so they've got a README, they've got some haddock docs. They have some sample code in their haddock docs. They have some sample code in their README. General rule of thumb, if code is not regularly run through a compiler, it will bit rot. I know code shouldn't bit rot, I know reproducible builds, blah, 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 but in practice, everyone changes everything, and the README and the haddocks will fall out of date. So, if there isn't a tool checking they're all correct, find some examples that look a little bit complicated, try them, and you'll probably find they don't work. And this is another example of one of these threads. So you pull on this thread, oh, your documentation's out of date, your README no longer works, your haddock things don't work. Now, this is a great excuse to start adding, say, doc check or an analysis for the README or something like that to make sure it doesn't happen again and to fix all instances. So yeah, a way of kind of pulling yourself up to a bigger project, a more useful project. I will say, this is the kind of thing that it seems there should be done centrally, but I've never seen a good tool that can do it for all projects, because all projects require these slight customizations. So I've written it myself in about 4 projects, but never with enough that I could reuse it across all the projects. So maybe that's a good idea for a project for someone. So finally on the docs topic, is the bug tracker clean? So bug trackers accumulate cruft. Bugs come in, there are hundreds of bugs. No one bothers going through their bug tracker. I was a little bit nervous about including this, because usually the bug tracker requires a lot of context that only the maintainer has. And you don't want to just generate useless diffs. But maybe go through the bug checker if you're feeling generous to a project, but maybe not. I was a little bit skeptical about this one. Okay, so that's it for docs. Anyone got any other thoughts they'd like to raise on how you can contribute to docs? Nope. Moving on. Static analysis. So I love static analysis. I did a PhD on static analysis, so I think this is the more fun topic. But docs are kind of a much better introduction to this kind of stuff. So the idea of a static checker is you take the code, you run some tool on it, the tool says, there is a problem here. The problem with all static analysis is sometimes they say there is a problem here and there isn't, and they miss lots of problems. So static analysis isn't a guaranteed win, but if you take a static analyzer that hasn't been run on a project, run it, and chase down a few of these possible leads, you'll almost certainly stumble onto something, and that something may be widespread, it may happen in more places. I will say, for these static analysis tools, use them to find bugs, and tell the maintainer, oh, I used this tool to find this bug. The maintainer might go, wow, that's so awesome, I want to integrate the static analysis tool, or they might say, thank you for the bug report. It's kind of their call whether they integrate them. I typically would. But find the bugs this way. So the static analyzer that everyone uses is the warning flag, -wall. So this turns on all warnings for GHC. You can, simple as turning cabal build, GHC options, -wall. And you can get a list of all the warnings in a project. I would pipe it to a file, have a little search through. So since I thought I'd actually dog food this talk, I tried it on Shake, and there were 895 warnings. Seems like quite a lot. Does this mean Shake is garbage? No. I think they fell into 4 categories, things like name shadowing, which I often do deliberately to hide an identifier, unused argument in Lambda, which is because of a pattern my test suite follows. It's quite common, and a couple of other things. But going through that, I did find one that looked unusual or different. So that was shake classes, warning, dodgy exports. The item typable suggests that typable has methods, but it has none. And this isn't an answer of, oh, I should go and delete the ... from typable, but it's a thread to pull on. It's something to learn about. It's something that maybe I should. And the hope is you can find some really nice bugs in the code. As it happens, typable changed interface between GHC versions, so actually on older versions of shake, this was a perfectly legitimate definition, but now it isn't. So maybe I should probably remove the ... It has a semantic change, but probably the right semantic change. Yep. Yes, maybe I should probably go through and, well, so having now gone through the 895, there are about 4 warnings I don't follow. Maybe it's worth writing those 4 down and turning on wall and then disabling those 4. Partly, I tend not to do that because GHC adds and removes warnings between versions. So coming up with the warning flags that turn off warnings, you want to disable warnings on newer compilers, but not on older compilers, but you can't pass the flag to older compilers because then you'll get a failure. So it's a bit of a mess. To be fair, before like yesterday, I had never run shake with wall, so I had no idea what I would find. As it turns out, 4 plus this one. Anything else? Okay, so wall, a lot of projects already use it. So let's look at another static checker. So who here has used HLint? Okay, I'd say most of you actually. Oh, wow. Okay, so you can run HLint and see what warnings it suggests. So it's as simple as cabal install HLint, the directory you want to check, ---- report will write out a little HTML report, which makes it nice and easy. So this is a little sample report at the bottom. So it's saying things like, you used folder1 &&, you should have used and be careful, this removes an error on empty list, which you probably didn't want in the first place, so maybe this is actually fixing a bug. But the idea of HLint is very much, it's improving the quality of the code. It's not improving the performance, these will both run equivalently fast, but it's making the code simpler, more readable. And HLint, if you run it on a big project, will probably generate lots of warnings. So search for the good stuff. So I ran HLint on shake, try my own dog food, and this was one of the warnings it suggested. It found, essentially, this code in one of my modules. So I declared the language constraint kinds, and then on the very next line, I declared the language constraint kinds again. Kind of, well, that's totally pointless. Clean up the code, make it prettier, delete the second one or the first one. Doesn't really matter. So HLint, it's good for finding stuff that often the result of refactoring. So I suspect these were 2 separate modules and I pasted them together and put their language lines both in. But obviously I never did the kind of full writing it from scratch pass. So HLint does lots of stylistic things like here's a redundant lambda, this do isn't needed. Lots of things that are nice as a maintainer to have, but not great for contributors to produce. But some of the good stuff it does are removing redundant language extensions. So GHC has a flag to remove redundant imports, and in my opinion, it really, really needs one to remove redundant language extensions. But it doesn't have it. So HLint is kind of the missing piece that GHC should probably get itself. Another one is it can detect uses of mapm when you should have meant mapm underscore. So this is often a fantastic performance boost. Often it will only be in the test suite or something, but if you can find it in real code, it's really worth having. And it will also suggest things like concat map, where you've used concat and map next to each other. Sometimes because you've used concat, you use something other than map, and then later you replaced it with a map, and these 2 things have kind of come together over time. So HLint just kind of looks for the simple stuff. So yeah, make all the changes you think are valid, don't just follow HLint, and then submit a patch to the maintainer. So I kind of wrote this talk and I thought, there isn't enough actual Haskell code in it. I went to a conference a couple of weeks ago. I was really sad that I saw no actual Haskell or even any language code in it. So I thought, I'm not going to go there. So I'm going to just digress for a couple of slides to explain slightly how HLint works. So it's nothing complicated. To a first approximation, it passes the source code using the Haskell sourcex library. So this is a library where you give it a Haskell piece of Haskell code, and it'll give you a syntax tree with annotations for source locations. Doesn't support all the GHC features, but it's pretty close. 99.9% of files will go through with this. Then I traverse this syntax tree using Uniplate, which is a generics library. And then some of the hints, like redundant extensions, are hard-coded in a file. So there is if an extension is twice, snip it out. If you haven't used the lambda case syntactic constructor in an expression, then you don't need the lambda case extension. But most of the hints, so things like concat map, like the fold L1, ampersand is and, are just encoded as little blocks of YAML. So it's literally if the left-hand side looks like this, then suggest the right-hand side, where any single letter variable is a replacement substitution thing. So if you write map uncurry something, whatever, uncurry plus, zip x, y, it will suggest, well, didn't you mean zip with plus? And if you think of additional hints that would be useful, you can add them yourself or submit them as a patch to HLint. And how does HLint works? Well, it basically does all that, and it's lots of plumbing, but there's no real smarts. I guess the smartest bit is the bit that find ideas, takes the list of rules, so this left-right pair, scope information, so give an identifier, what module did it come from, a decal, which is a single Haskell declaration, like a function, a data type, an instance, and produces a list of ideas. So this is what I should replace this with that. And it's a big list comp in the middle. Nothing too interesting, but I thought I'd just kind of delve slightly into the Haskell. I guess the interesting bit here is universe parent exp, which essentially, given a declaration, gives me every expression with its parent expression, so I know the context it lives in. Any questions? Okay, moving on. So, most people have used HLint. Who's used weeder? Wow, I'm quite impressed for a tool that is only on my GitHub and entirely unannounced. But you can use weeder. So this is another static checker, not the same as HLint, but the kind of same staticness as HLint. So the idea is it finds the weeds in your program. So I kind of, if you look at a Haskell program, if you miss something, if you delete something, the compiler will tell you to put it back in. If you delete an import, the compiler will go, I couldn't find this. If you delete an extension, it will say, I needed that extension. If you delete a package, Cabal will complain with, I needed this package. If you delete a definition, things will go, oh, I was referencing that. So there's lots of pressure to grow your project bigger and bigger and bigger. But I wanted pressure in the other direction to kind of only leave the useful stuff in your project. Otherwise, left unchecked, every project will eventually become big and bloated and have lots of junk in it. So weeder was my attempt to do that. So it's as simple as run weeder on the directory containing the pre-built project that you want to use. And you must build your project with stack to run weeder on it, because it uses some of the metadata stack generates. So if you run weeder on something like GHCID, it prints out this. So the two weeds it spotted are, well, the GHCID module is used between the exe and the test. So this means Cabal will compile it twice, and it will go a bit slower. Yeah, maybe that's a problem, maybe it's not. In this case, I know that I deliberately did that because I want to test internals in GHCID that I don't want to put into a library. The other weed it's spotted is that the with waiter poll function is exported from wait, but isn't used anywhere else in an externally visible way. So the with waiter poll export is a weed. Does that make sense? So the idea is I found this module that exports this function that isn't used. So now I go to that module and I remove the export of that function. Weeder has told me that's a safe thing to do, but you should probably check it by compiling as well. And now, hopefully, the GHC unused definition warning will kick in, and I can delete the source of that definition as well. And now, hopefully, the GHC unused import module warning will kick in, and I can delete the import. And now the HLint unused extension warning will kick in, and I can delete the extension. So Weeder is very much, kind of step one to try and cut down your export list so that all the other warnings kick in and delete lots of stuff. Another warning it will do, which is quite useful, is if a package is declared as a dependency in your Cabal file, but not actually used by any of your projects, by any of the modules, it will suggest deleting it. In this way, it does exactly what the packdeps tool does, but it turned out to be easy to edit here. So, how does Weeder work internally? Basically, when Stack does a compilation, it dumps all the HI file contents to a text file, and Weeder just passes all these HI files and then does some analysis on the stuff it thinks. So the HI says which packages you make use of, which modules you export, which definitions you export, which definitions you import, and it just does a kind of diff on all these things. And then once it's got all this data, it does an analysis pass. So for example, if a function is exported but not imported anywhere, then it's a weed. Nothing too clever. And just to give a flavor of the kind of things that are in the HI file, well, so you've got the module name. That seems pretty important for an HI file. You've got which packages are imported. So this is dead easy to do, which packages are unused. You've got which identifiers are exported. So some of these are exports directly, some are re-exports. You've got which identifiers are imported. So for first approximation, you just diff those lists and you get the ones that are imported but never exported, and that kind of thing. So since Weeder is relatively new, if you take it and run it on a big project, you might find a whole chunk of dead code that no one knew was lying around, and then you can remove it. So this is a great thing to run on new projects, because while often projects will have run wool, only 4 people in this room would like to have run Weeder on their project. So for both HLint and Weeder, they both have binary releases on GitHub. So I don't usually make binary releases of my Haskell projects. I don't think many people do, but they do. And that's so you can run them on things like Travis or Appfair without installing all their dependencies or without bloating your compile times just to get the static checker. And to run, say, HLint on Travis, it's as simple as this command line where this dot is the argument to HLint. Essentially, there's a shell script that you can use to boot up, downloading HLint, running it with your command line, and then clearing it all up afterwards. So very easy to add. And both of them also have ignore YAML files. So with Weeder, you can do this. With HLint, you can do this. Pipe them into a .HLint or a .weeder.yaml, and now it will ignore all the existing warnings. So if you're a maintainer, this is a nice way to start turning on HLint without worrying about any of the existing warnings. If you're coming at the project, it's a nice way to generate these files, then go through the YAML kind of turn off file to see the warnings and turn on the ones you think might be useful. Okay? Okay, any questions on static or any other static analysis tools you think people should be using but aren't? So the automatic formatter is hindent, and it won't pass most of my code. And it screws up comments in do blocks. I'm torn on whether automatic formatting is a good idea. My suspicion is that if it is, HIndent isn't quite good enough to do it yet. Any other static analysis tools? So, yep. Yes, I think I've got it in the next section under testing rather than static, but yes. But yes, that is good. No, totally. It works on applications, libraries, things with applications and libraries in the same thing. No, it's much better for libraries in many ways. So it looks for things that are exposed. So you have exposed modules and other modules. So something like text where it's decided to dump its entire internals into the world, that's not going to have much success. But things which have more carefully chosen exports will. So partly the reason I put it after the documentation is hopefully by this stage you've gone through their Haddock code, and if there were completely unused functions that shouldn't have leaked out into Haddock, you deleted them already, or unused modules. And now Reader can clean up the rest. Yes, I did. Plans, but I'd be surprised if it happened. I have many plans, unfortunately. So yes, I mean, as I said, I did my PhD in static analysis. I wrote a static analyzer for Haskell, and it's not on this list because it no longer works, which is sad. The list is also woefully short. I mean, static analysis. Haskell should be great for static analysis. We should have hundreds of static analysis tools. Everyone should be running them. But alas, I guess I like static analysis too much. Cool. It's not really. I mean, their warnings, they're a little bit shallow for my liking. Pattern match error should be, it will be a pattern match error, not you failed to syntactically enumerate the cases. Not the same. I get nostalgic for real static analysis. It could, but it's not a per module property. So things like unused extensions could be part of GHC because it's a per module thing, and GHC is very per module. But unused exports, it's a global property. And there's also a question of in which context. There's also a lot of, Reader, to a first approximation, takes the difference between the two sets. But in reality, there are lots of things. So if you re-export it twice, but then never use the re-export, is that a bug? If you export the field name, but only use the constructor, is that a weed? So there's more complexity, possibly more heuristics than you'd want to go into a compiler. I believe GHC will warn about them, and I think intro will certainly delete unused imports. I'm not sure if it will delete unused fields within an import, but it seems like it could do. Cool. Okay, moving on to testing. So tests are great. I think everyone would probably agree with that, but writing good tests takes a lot of time, and people often forget it. So if you find tests that are missing and write those tests, the maintainer will be grateful because that was annoying, depressing work that they don't have to do. But probably if you test something, you'll also find bugs. So that's another interesting thread where you can go and fix it so it passes your test. But beware, tests are not always good. There's this trade-off. If a test is if a piece of code is one line, probably doesn't need a test, probably obviously correct. If tests take forever, then they're probably not great. So you don't want to add 10 minutes to your continuous integration tests just so you can check one line a billion times with quick check. And tests that are prone to high maintenance aren't good. But generally, tests are great. So where can you find the inspiration to write new tests for a piece of code? So the first place to look is bug reports. So given a bug report, does it have a reproducible test case? If not, write it. Is the test case machine checked? So does the test case say, well, eyeball it and you should see green green here? Or does it like return something, return an exception if it fails and nothing if it doesn't? And then finally, is the test ready to go into the test suite? So often, so for example, for HLint, I'll get a bug report, which is a Haskell file I can run. But the test suite doesn't just have Haskell files I run. They're formatted differently. They're stored differently. There's a little bit of noise around them. So doing that work and submitting a pull request for the test, even without fixing the bug, has some value. And of course, now you have your test, you can think about, so now you have your test, does it actually work? So a lot of bugs tend to get fixed by other changes without people realizing, and people didn't realize they fixed a bug. And if not, if it's still broken, you can roll up your sleeves and fix it. So it's a kind of good stepping stone to doing something slightly bigger. The other way to find missing tests is to run HPC. So I ran HLint, not the test suite, I just ran it on a few examples, with HPC. So HPC is the Haskell program coverage tool. It's built into GHC. It's as simple as passing FHPC when compiling, and then at the end you have to run the HPC tool to generate some files. It's in the user manual, GHC user manual, it's quite handy. So this is an example of the HLint output. So HLint never evaluated this expression, or this expression, or this expression, or this expression, and this condition was always true. So length of L was always greater than 1. So it seems a bit weird, this length of L is greater than 1. It just seems an odd condition. Is it really necessary? Is there any way to hit it? If I write a test case that has L less than 1, and it gets here, will that do the wrong thing? So this is a great example of somewhere you can kind of try and figure out how to get to this code and write a test for it. So with HPC, do look for the sweet spot. So look for code that is not obviously correct. It is untested, because HPC told you so. And then add a test based on its docs. If its docs don't tell you what it should do in this case, go and fix the docs. I would say never aim for 100% HPC coverage. Whenever I've done this, it's been a disaster. You end up writing tests that don't exercise the code, they just touch the code. So if you're not checking the result of the code is meaningful and you're just covering it, you really haven't added a test, but you've added your HPC stats. So I would say don't aim for 100%, but one day hopefully you might reach something high. And seemingly incentives do matter, which is why things like coveralls, I don't use them, because that's a service that will run HPC on your code and report a nice little badge of what percentage you're on. When I put that badge on, I started screwing up my test suite, so I quickly ripped it out. And as said, run your tests on AppVeyor and Travis. So of the maintainers, who doesn't use AppVeyor or Travis? I'm looking at you with evil eyes. Do it. It's the only way you'll... so as soon as you get your code on AppVeyor and Travis, you can merge commits from your mobile phone. You don't have to download the patch and check it actually compiles. You know all this, you just press merge while you're still in bed in the morning. It's great. So basically, there's Travis for Linux and Mac and AppVeyor for Windows. They're very time-consuming to set up, because you basically have to kind of find your way in the dark, add a few configuration options, wait till it works. So doing this for a maintainer would be greatly appreciated. There's also a lot of variety. So Herbert provides a PPA archive of the GHC binaries that I use on Travis. You can use stacks. I use stack on AppVeyor. And because these things are painful to set up, I have them set up centrally for all my projects, and then have bootstrap scripts to get them started. So what do I mean by that? So in each repo I've written, you'll see a something like this in the Travis script. So basically, it curls off, grabs a shell script out of a shared repo for all my projects, and runs it. And this thing calls a centralized shell script that has all the apt-get install ghc vir, cabal install neil, run neil. Neil is my kind of project where I put all the things that are just for me. It isn't even released to Hackage, or wasn't until recently. And then essentially this shell script boots into some Haskell code that then actually runs all the checks I'd like to have done on all my projects. So it checks, for example, there are no Windows new lines in my source files. It installs cleanly. I didn't miss any packages. Everything's documented using the haddock ---- Hugel trick I referred to earlier. I've got lowercase for my cabal files. I've got the right copyright here. Basically, anything I want, I'd like all my projects to follow this. I just add it here, and they just start failing the CI, and I go fix them up. It'd be nice if there was some generic way which was slightly more general than just Neil. If anyone wants to take that code, make it general, support it, do all those things, and make it usable for everyone, call it anyone rather than just Neil, maybe. Okay, so that's it on testing. Anyone else, anything for testing? I don't use any of the off-the-shelf sorts. So yes, checking your documentation and writing your documentation in the tests, the tests from the documentation. So yeah, I do this for both file path and extra very heavily. I haven't found a good tool that does it generically. I've always wanted special cases, but yeah, it is great to have doc check if you can, some form of that. Yeah, I didn't like it because it's all in shell script, which made me sad. And it doesn't do all my custom checks. But yeah, that's probably the place to start if you're just going for a new maintainer. I think Michael Steinman has an equivalent one for Stack, because of course they could never use the same one. Anything else? Yeah. A lot of the code is easier to test because they have no I/O, and so a lot of languages seem to have become obsessed on mocking as the way to test things. I remain thoroughly unconvinced that mocking is of any use whatsoever, but seemingly in Haskell it's not a problem because usually, if your code isn't doing I/O, it would usually be polymorphic in the monad it was doing it. So it can do I/O, but it doesn't have to do I/O. And then you would test the version that doesn't bother doing I/O. Or the version that also does logging, so you can check that the state is what you expect. So there are lots of ways to do this. But there are lots of ways for different cases. I wouldn't say there's like one bullet for all of them. Okay, on to the last one, performance. So, it is nice for code to be smaller, faster, use less memory, all these things. So this is a nice thing, given any project, if you ask the maintainer, can I make it faster? The usual answer is, yeah, that sounds great. But before you bother making something faster, you should make it sure it's well did, so that when you make it faster, you don't also make it wrong. I had a lecturer at university who said, there's no point measuring the performance of something that's wrong, because you can always make something that's faster and still wrong. Just know what. So, of course, before you start improving the performance of a project, do check that actually performance matters to this project. It will to most, but if it only takes like 1 millisecond in total and it's run once a year, no one's going to care if you make it 20% faster. No one's going to be able to measure it. And even if it's running yearly, doesn't matter. If you have to compile GHC and then run this script, and this script takes like a minute, well, the compile of GHC just took me 20 minutes, so it's hard to care. The other thing is all these kind of things apply to memory. If it's using like 10 megs, does anyone care? Unless you've got like a server farm of them on an embedded Pi or something. But that said, otherwise, performance is great. So performance optimization, as a beginner, and probably even as an expert, is essentially take the thing, measure it. How fast does it go? Whack it with a hammer somewhere, measure it again. Did it go faster? If it goes faster, oh great, submit a pull request. So really, all the things I'm going to show after now are just how to direct your whack, giving you clues where the whack might land. But ultimately, they help you focus on a lump of code, and then you still just apply whacks mostly randomly. So who's used GHC's time profiling? Yeah, it's built in, it's pretty good. If you've used other languages, it's amazing. If you've used GHC, it seems a bit clunky, you know, couldn't they have done this better? But it's serviceable. So there are lots of flags to turn on profiling and turn on different settings in the profiling, but just something like prof auto all usually works, and then you run with plus RTS minus P. So I profiled HLint, generates 6,500 lines, which seems a lot. But at the very top is a table. And this says, these functions took most time. So just to kind of give you a flavor of how to read this. So cost center, this is basically the name of the function, or sometimes it's a bit within a function, like a binding within a function. Module, so module that cost center is in. Time, so this is the time that was spent inside this function, but not inside the functions it calls. And alloc is just the same, but for memory. So looking at HLint, I can see unify exp takes 23% and find ideas takes 10%. Then I've got some things from Uniplate floating around, and then here, push L context, so this is Haskell source X parsing. Okay, so some intro information. Two slides. You didn't hear that. And then also, it displays, so after this top 10 lines, which you can probably read, it displays like 6,000 lines of ever so slightly indented stuff. Basically, for each function, it says how much time was spent inside this function itself, how much time was spent in this function and all the functions beneath it, so the inherited time. So they refer to this as individual and this is inherited, and how many times was it called. So how many times was it called? Sometimes it's a useful number, sometimes it's garbage. Like, I called unifyX 16 million times, and that called the is.dot function 3 times. I'm thinking it's probably lying to me. And it often does. But, you know, it's better than nothing. And so I formatted this nicely so you can see it. In reality, this was not easy to see. But yeah, you can see like unifyX takes 29%, inherited 23%. And, oh, where's the inherited time? Oh, so match idea and nmop take a bit of that. Do these numbers add up? No, not even close. And that is actually life with GHC profiles. Fortunately, there's an easier way to view it, using a tool by Jasper called Profiter. So you just run Profiter over your profile file, and it generates an HTML file that you can interactively browse. And essentially, this is the whole program, and then you can double-click on any piece to kind of explode it into its constituent parts. And what I've done here is I've exploded down to unifyX, which Kibal said, which the GHC profiling said was quite interesting. And you can see that takes up a 29% sized window on the screen. But I can also go, this strip of green here, I wasn't really expecting that. Where did that go? And drill into it. And there's also tools to reroute it. So if I just want to look at pieces, I can do that. Any question? No, I clicked you have to double click each time as well, so it's doubling the clicks. No, it's quite difficult to, well, especially if you're tweaking, doing it again, often you'll end up repeating the same set of brrr, and usually you just want to click on the biggest thing on the screen. So yeah, it's good. And basically with a profile, every time you view it in a new way, you'll see a new thing. But yeah, there are limits to the GUI approach. Which bit? Oh, it's just area. It's just area. It's just how it's chosen to tessellate it. Okay, so this is one way of viewing it, but with profiles, every way you can view it will teach you a new thing. So there is a new package called Profiterole, which also lets you view profiles in a new way. How many people have used Profiterole? Great. So it's not on Stackage yet. I only added it like 3 days ago. So the idea is that Profiterole will take your tree, your profile tree, and munge it into the profile tree you really wished GHC had given you. In doing so, it throws away some information, but information that makes it easier to read. So for HLint, it goes from 6,000 lines to 442 lines. So the rough idea is it tries to find pieces, fragments of profile tree that are called from multiple, which have multiple different roots. Then it takes them, sucks them up to the top, merges them, so you see a new root which has a piece of the tree. And if we look at this profile, this is like the top summary from Profiterole, which actually does look pretty much like this. So read match takes 51% of the time. So with Profiterole, so before with GHC, there was how much time do I spend in here, and how much time do I spend in here and in all my children. With Profiterole, that's slightly different. Individual is exactly the same as before. Inherited is now how much time do I spend in myself and my children, not including any children who I decided to drag up to the root. And then total is including the children I dragged up to the root. So in particular now, read match is 51%. So this is the matching engine in HLint. Read cache follower is 12% of the time. So this wasn't even on the original profiler. So I've seen a whole new hotspot I didn't know I had before. Pass file contents with comments takes 10% of the time. So unsurprisingly, HLint spends a lot of time parsing the files. And now I can actually see it on the profile, which is great to see. And Profiterole also provides like a tree view, just like GHC. The only difference is the tree views are a lot shorter because anything with a deep root has been yanked to the top. So in a normal GHC profiler, I would actually have read cache follower 155 times in those 6,000 lines, each taking up barely a fraction, something like 0.1 or 0.0. What Profiterole does is it grabs all those read cache followers, pulls them all out to the top, and sums up their numbers. So Profiterole, before, I could find 0.1s for it. Now I find a single 12%, and I can see that actually set unions is on 6.2%, and follower is on 4.1%. So I can actually see where the time's going, especially if it's called many times and does only a little bit of work. So try these tools. You might see something new. You might find somewhere new to whack. You might find something cool. So how does Profiterole work? Very quickly, there's a GHC prof library that reads the GHC profile. It builds a tree, finds things to suck up to the top, sucks them up to the top and merges them, and then writes it back out. And yeah, it can reduce profiles from like 200,000 lines, which won't even load in my text editor of choice, to 5,000 lines, where I can actually meaningfully scan it. So that was time profiling. GHC does have memory profiling. You can generate pretty graphs. Memory profiling, to me, is somewhat of a black art still. Time profiling really does kind of give you all the information, and then you look at the profile a lot to extract the information you want. Memory profiling seemingly each time I think, oh, what's going on here? I have to do a new run of the same program with different memory profiling flags on the plus RTS. It just takes an awful long time to figure out anything. So, yeah, can memory profile, but it sucks. Stack profiling. So some programs use too much stack, and often this is due to a space leak. So when there's memory being retained by lazy thunks that should be forced, and there's a little recipe for how to do it. Rather than go through it now, I will say this recipe is on this link, and these slides are all on my website. And it's found space leaks in vector, base, quick check, happy, statistics, got one recently. Yeah, essentially, any program you apply these techniques to, you're likely to find a space leak. And since space leaks are always bad, probably a good thing to start and tell the maintainer about. Okay, so I've waffled on for enough. Hopefully this has inspired you to go out and contribute to some of the Haskell projects. Any questions? Or ideas I've missed? So the GHC HI files do that, and Haddock does that as well. So in fact, Haddock minus, are you looking exported externally to the user or just? I think there's a GHC warning you can say that will generate you the module list you should have pasted in. I think, but it's been added to various editors at various points, but I'm not sure if there is a tool that exists. Yep. Oh, give up. So the problem with something like vector fusion heavy code is essentially under anything but the most aggressive compiler settings, the performance is radically different from what you will normally get. So as soon as you turn on profiling, you turn off enough of the vector fusion to mean the vector fusion is now somewhat meaningless as a profile. So yeah, I have no idea.